example 6, we're using case 3 because if you look, we have something more than just a linear expression. We have a squared here, and they're not repeating. So that's why we use the quadratic with non-repeating, okay? So essentially, whenever you have a squared, on the top, you're going to write the variable x plus another variable, okay? So this first one, x minus 1, is linear. So we're just going to have a variable, okay? So we put x. The second one right here, x squared plus 9, is quadratic. So we have to do variable x plus variable, okay? So we're just following this little chart here, okay? So now, from here, we do the same thing that we've been doing. Our goal is to make all the denominators the same. So we want them to look like this, right? So this a is missing x squared plus 9, so that's why we multiply by it. And then this b, x plus c, is missing the x minus 1, so we multiply by that. Okay? And then we do some algebra. We FOIL over here, and we distribute this a over here, and then we also add our descending numbers here. It goes all the way up to x squared, so we're going to have our 0x squared plus 0x, and then we still have our 10. And then we can combine all of our x squareds. Because they all have x squared, we know that they're going to cancel out, so we can actually just get rid of that from the jump and just do 0 equals a plus b. Okay, and then we have 0 equals negative b plus c, and then we have 10 is equal to 9a minus c, okay? So that's where this first word comes from. All right, now, this is just like the other one where it didn't spit out like the other one did last time. I think on example 3 when we worked it, or example 4, when we did it this way, one of the letters just spit out, but that didn't happen. And that also didn't happen on example 5, but for example 5, we just went back to the other way, right? So when this didn't work, we went back here and tried to plug in numbers for our x to try to solve for a and b, but this is a little bit more complex than the other one, right? So essentially what we're going to do is just solve for one variable for this green section. So I just moved the b over, okay? So we know that a is the same thing as negative b, okay? Negated b. So now we're going to take this information and bring it over to the red information. So now we know now that negative b is the same thing as a. So I'm going to plug in a, okay? And now we'll do the same thing. If we solve for a, we'll move that c to the other side. So we have c is equal to, we have a is equal to negative c, okay? And now we move over to the black, okay? So now instead of a, we are now going to write negative c, okay? So that's where this negative c came from the red portion. And then we have negative c, okay? Then we do a little algebra, and we get c is equal to negative 4. And now we can work backwards and plug in our numbers. So if c is negative 1, when we plug in negative 1 here, it'll become positive. When we plug in a 1 here, we get negative 1, okay? So that's how we find our variables. And then we go back up to this top portion and just plug in our a, b, and our c, and we end up with this. And I went ahead and separated them into 2 parts, okay? Ooh, sorry, I didn't realize that my video had slanted. My bad. All right, so from here, there's no power, so we can use our absolute value, or our natural log absolute value rule. The derivative of the bottom here is 1, so that works out perfectly. And then over here, remember whenever you have multiple parts on the top, as long as you keep the denominator the same, you can split them up. So here I did the negative x, and then over here I did the negative 1, okay? If you look on page 81, number 17, you'll see this little thing here. I am going to provide you with that list, that whole list on page 81. So all you have to do is know how to apply it, okay? So yeah, essentially, with this problem, let me get something to write with that you can see. With this problem, our a here is, where are we? Oh, no, sorry. I'm still on the, this first one. So when we take the derivative of the bottom here, we get 2x, right? This only says x, which means we need a 2. So we add the 2, we multiply by the 2, which means now we have to divide by the 2 to cancel it out, okay? So now, this whole integral here, we can use our natural log absolute value trick and just bring down the half, okay? So let me run through that again. Just like this interval right here, the derivative of the bottom, x minus 1, is 1. It already has a 1. So we do the natural log absolute value of the bottom, okay? Here, the derivative of the bottom is 2x. On the top only has an x. So we're going to put the 2, but since we're multiplying by the 2, we have to reverse that by dividing by 2. So now this blue box, we can do the natural log absolute value of the bottom, okay? And then just bring that half down. Perfect. And then for this last term, I already said that we're going to use number 17, and you just plug in. So we look and we see that our a is a squared is 9, which means our a is going to be 3. And then we see that our u is x, right? So we just plug that in. So it's going to be 1 over a, which is 3, tangent inverse x over 3 plus c. And that would be our final answer.